Go ahead and play some beats for you because why not? So let's just hit play. Play some royalty-free music while we get into this. So, Kubernetes. For those of you who've been trying to learn Kubernetes, Docker, things like that, I've been talking about, things like hardware that's good to work with Kubernetes. We've been talking about, some of the things that we've been doing. But, what are some tools that we use for Kubernetes? And we've talked about Kubernetes a little bit before. We've been talking about it for the past, last month anyways.
Yep.
So we were talking about different flavors of Kubernetes, hardware that's fun to play with Kubernetes, but let's kind of focus a little bit on how can you start learning. And I'm just going to say that Rancher Labs, I've talked about Rancher Labs before. Rancher Labs has a pretty good version of Kubernetes for just kind of playing with, whether you're trying to create some like lightweight Kubernetes builds, or you're trying to try out a new project that you're trying to develop, or you're trying to learn. Whatever you're trying to do, Rancher Labs has some just really convenient versions of things of Kubernetes. They create things like Longhorn, which has pretty dashboards for Kubernetes-based storage, things like that. So you can see right here, this is what's called Kubernetes-based storage, because you can create storage in Kubernetes. You can host things like GitLab in Kubernetes. You can do all kinds of stuff in Kubernetes, and then you can use GitLab to keep it organized. And you can also host things like WordPress, your own WordPress, with your own databases, with your own things, not going to WordPress.com and saying, start website. You can actually just add WordPress to your Kubernetes build. So if you wanted to start trying to find like some easy ways to get working with some of these things, there are two tools in particular that I've talked about in the past, but K3S is one, and then there's one called K3D, and there's some others that are, work great too. But one of the things that I like when I'm developing anything is I like things that are relatively like minimal. And so if we're talking about like minimal, we're talking about like lightweight builds. So I guess like in terms of like Kubernetes, we primarily use like lightweight Kubernetes. And so I guess like Jordan, maybe you have a good explanation for like how do you explain like lightweight resources? We have like light Linux, we have like light Kubernetes, light other things. Like I guess how would you explain like what's light?
What a light version is? Well, I mean, it's software that you basically strip out features that are extraneous or that you don't need, so that you end up with a version of the software that still has the core functions that you need it to do, like whatever it is you want it to do, but with very little extra, so it doesn't take as many resources to run, and it doesn't take as much space up on whatever storage device you're using to deploy it, etc. Would you say that's pretty good?
That's a good way to put it. And so, like, if we just then say, like, this is lightweight Kubernetes.
Well, yeah, so, like, a good example outside of Kubernetes would be if you're looking at, like, Raspberry Pi OS, for instance. They have both a desktop and then a light version where you strip the desktop off and you just leave like the core components underneath, but then you need to understand how to use a command prompt in order to do anything with it. So
that's anyway. A good explanation. Let's see. So I'm just going to type a stripped down version of software or builds or whatever. And so it doesn't mean that, it's not like if we're talking about, say, like there's actually like a lightweight version of Windows, you could call it Windows Core, where Windows Core is quite literally like just if we just pull up a command prompter, like this is Windows Core. You'd not have a GUI.
Is that the do you get the PowerShell still?
So PowerShell is a separate application, so you would have to actually, and that's a very good question. So you can actually have Windows Core installed with PowerShell, but oftentimes like even like the light flavor of Windows doesn't even come with PowerShell.
Sure.
And Windows does have like a deployment tool that lets you like determine and define like what do you want to deploy. And so, with Linux, we have some similar things like that too. Like we could just go over to Ubuntu's website, which I don't know if it's ubuntu.com or something. If it's not ubuntu.com, then it's ubuntu.something. So I guess this is it. I don't care if they get my cookies.
Yeah, it's just .com, I believe.
Cool. So, sweet. So if we're taking a look at, say, like ubuntu.com, and I am just comparing, Kubernetes is not an operating system, so don't get too, like, for those who have never heard of Kubernetes, or you're just, like, checking out my stuff for the first time and you're still trying to figure these things out, Kubernetes is not an operating system, but Kubernetes it's software, and it's, I guess, software that makes it easier to build scalable software and supercomputing software, things like that. I guess that's a way to think about it. And we're talking about this concept of like lightweight. So if you were to go to like download for Ubuntu or anything, and we were to go over to, well, right here it says Ubuntu desktop, and then it says LTS. If I just like click on this Ubuntu, then we have this one that says Ubuntu desktop. It's got LTS or whatever, and it tells you a bunch of things that comes with and what that means. And you can download that, and what that means is it has a desktop. You can use a mouse with it. You don't have to use just a keyboard and all that good stuff. But what if you didn't want all of those extra resources? You can actually just go and get like Ubuntu. Like if you were to get a Ubuntu server or one of these other options like this, then what it's going to do is it's going, like, you could go to option 2, manual server installation. It's going to give us options for download Ubuntu server. And, I could keep clicking down the road. There's probably a faster way to get to the actual download. But one way or another is, if we're talking about, like, the Ubuntu server install or Ubuntu Lite install, generally speaking, we get a version of the operating system without a bunch of things that we don't need. So if you're just running a server, generally speaking, like that server might just be sitting in a dark closet somewhere with air conditioning to keep it from overheating itself. And so like you might have something like this just like sitting in a corner, which this is a teeny tiny server. It's actually a little supercomputer. And then it, you're not going to be spending your time, if you're running, say, a WordPress server, you're not necessarily, when you're using WordPress, you're browsing to it and you're setting up your media and you're setting up your pages, and you're probably using an external workstation. That's probably what you're doing. You're probably using a workstation versus, if you're using a desktop operating system, that's a little different. And so for those who are watching, I'm trying a different video stream thing, and sometimes it cuts out with the video, so if Jordan's video pops in and out, Jordan's still here. But Jordan, would you say that's a pretty good way to I guess, to explain, is just like, as you said, it's stripped down, but you don't have,
Well, I mean, here's another way of explaining it. Think of, like, if you buy a computer from Dell or HP or something, it's basically like the opposite of that. It doesn't come with like a million things that you don't want and that don't do anything and just fill up your hard drive with.
Yeah.
Sorry, that's kind of tongue in cheek, but I mean,
that's how I see it.
But yeah, I mean, it's just it only comes with the core components, and then basically anything that you want on top of that, you're going to have to get it yourself, probably.
Yeah, pretty much. And
but
so
it makes it's like it gives you kind of a blank slate with which to start. So that can be very nice if you're developing.
Yeah, and if you're developing, sometimes it's nice to have just like minimal everything. Especially if you like to make things like, you can make things custom without having a lightweight operating system. You can still go and have a desktop operating system. You can have a Ubuntu server operating system with a desktop that runs WordPress. But the reality is that some developers prefer to just let those resources be used for this and not let those resources be used to give you a start button and access to click on everything and all that good stuff, especially when you're going to be accessing these dashboards and desktops from a browser on a separate computer entirely. So, that's what we're talking about when we're talking about like lightweight. And so there are other versions of Kubernetes too. There's things like Minikube, which is a flavor of Kubernetes, which a lot of folks like that for developing and testing in. And then there's other flavors of Kubernetes like Kind, which is Kubernetes and Docker, which is a lot more kind of like K3D. So we talked about this a little bit in the last stream that we were doing, where there's different versions of Kubernetes. We got Minikube, we've got K3S. These you install on what's called bare metal, which you install it directly on the hardware. Versus we got K3D, and we have Kind, which is Kubernetes that you install inside of Docker. And then I keep getting questions. Why do you use Docker with Kubernetes? And Docker has vulnerabilities. Everything has vulnerabilities. Believe it or not, Kubernetes has vulnerabilities. Windows has vulnerabilities. Linux has vulnerabilities. So does OS 10. Wait a minute. Here we go. Everything has vulnerabilities. So if your thoughts are to never use Docker for anything, including things like making Kubernetes easier to work with because of security purposes or vulnerability purposes, it has more to do with understanding how ports work. What makes Docker more vulnerable than Kubernetes is oftentimes like Kubernetes is a lot more work to get certain things working a certain way, and it's really easy with Docker to just accidentally not really have things situated in a way that's going to keep you secure. So but at the same time, Docker is much easier to like build things in rapidly and all those things, but then Kubernetes brings like resilience when you're trying to build things. So right now, like if you're trying to get serious at Kubernetes and you want to just kind of get started with building some things, I really like building with K3S, if I'm just going to be blunt. It's convenient, it lets you do things, and then better yet, let's say that you want to experiment with K3S and build things rapidly with K3S, then you can come in here and you can build, let's see, I closed the terminal for it. Maybe I didn't close the terminal for it. You can build K3D clusters, which I built a little K3D cluster right here, which is a lightweight, minimal K3S build. And so for anyone wondering, how can you get started with learning like what this thing is that I just highlighted is, because it's really anticlimactic looking at command line in streams. Actually, I don't know if anyone can actually see that, so let me see if I can share the little terminal that's showing on my screen, because I don't think that I have that showing.
I do apologize if my camera keeps going in and out, so to anybody watching.
Yeah, maybe we'll use a different video manager next time. I guess I have my stream set up in a way to where it doesn't show everything on my screen for security purposes, so sometimes even I have more security. So maybe I need to set up a stream sometime that's designed to show our Kubernetes lab. But if I go... Actually, I have another way to access that where it'll show it on the screen, because I have this little Athena Zero broker, which I can come in here, log in a bunch of things. I have so many ways to get through my network, it's kind of terrifying. But it's all protected behind things, so just because you can see things doesn't mean you can get into my network. So I'm going to say SSH, and then I have a special network that I have things connected to. So let's say, let's see if this will, K3D cluster list. Boom. There you go. So there are a lot of ways to access your stuff or whatever, whether it's through Docker containers, because I use a Docker container to connect to things when I don't have other ways to connect to things, because security. Because even this virtual machine right here, this little thing, if I were to try to access my own stuff, because security matters, I'll just show you and say the same thing. So I could try to connect to, from a different terminal, and that one's because of other various reasons. But anyways, it's good to have your stuff protected. But here we go. We have like a little Kubernetes, I guess, cluster. And I could go a little deeper into how to configure all of that, but instead what I'd like to do is spend a little more time talking about like what this is, because I mean, what this is called K3D. And what K3D is based on is something called K3S. And whatever you can do in K3D for the most part, if you can build something in K3D, you can build it elsewhere or send it elsewhere. And it's just going to work like Kubernetes. And then you can attach it to other versions of Kubernetes. And one thing that I like about K3D is it makes it really easy to make different versions of Kubernetes talk. So I'll show you what I mean by that. So let's say that you do use Minikube, because I don't think that any of them are the wrong one to use or the right one to use or any of the above, is you can actually make, you can use K3D to very easily connect, say, like a Minikube instance. And then let's say that you want to then connect a kind instance as well that's also in Docker. And then let's say that you also want to connect K3S. If you just start with like a K3D container, you can connect to multiple clouds. Kubernetes, they're all friends. I've seen this in social media where people will be like, you shouldn't use that version of Kubernetes. Well, Kubernetes could care less what version of Kubernetes you use. That's like a personal opinion. As long as things work, then it's generally opinion. Can the goal get accomplished? Can the goal be met with whatever flavor of Kubernetes? Awesome. And the best thing about that is there's no wrong version to accidentally use first, generally speaking, as long as you're using one of the primary versions of Kubernetes, especially if you're building like applications. There are limitations to that. They have differences, yes, don't get me wrong. But if we're just talking about like the core things that make Kubernetes, I like K3D because K3D is the minimal set of Kubernetes things that works with Kubernetes. And so you can use it with Kubernetes that might be living, you might have K8s in Azure. Matter of fact, you can connect your K3D to K8s living in Azure. As a matter of fact, you can sit here and you can connect the whole thing to K8s in AWS as well. Because Kubernetes is also known as K8s. But just to kind of get the idea going here, I like things that make life easier and faster. And when you're working with this stuff a lot and you're like basically trying to like spin up clusters rapidly all the time on a frequent, regular basis, and you don't really have time to waste, if there's something that lets you just experiment for everything and experiment with everything and also make it so that it's easier for things to talk, I honestly just really love K3D because it's minimal. It has the base things that other Kubernetes need to work. It has that. And if I'm trying to build anything in Kubernetes, I just want something that works. I could care less about a lot of things in life. I just like, there's so much that needs to be accomplished on a regular basis. Like I'm doing engineering with like companies who are, we're trying to, grow right now and get this product growing. And then, I have my little side projects that I do. I have like the Olympiad and all this stuff. So if I'm swimming in like K8s all day long, all night long, I don't want to spend my whole day trying to figure out the difference between all the different Kubernetes and trying to when literally just one thing can talk to all of them and one thing can be used to test with all of them and do certain things. Yes, I might have to then take something from a K3D build and port it to another environment that has other features on top of what K3S can do, because K3D is basically K3S in a Docker container. Same with K3S. If I can do it in K3S, I can do it in Kind, I can do it in K8S, because K3D and K8S, it's the same Kubernetes, just one's in a Docker container, one's not in a Docker container. And so, you can do things like have, how do I explain this? You can do things like have, let's start a new little board here. Let's say that you have a system, and we'll just call it a system. I don't care what system it is. A system, because Kubernetes can run on systems. It could be a Pi, it could be a Macintosh computer, laptop, desktop, doesn't matter. Could be a Mac Mini, could be a Windows computer, could be a Windows laptop. I really don't care what it is. let's say that we want to install on that computer. Let's say that at the base of it, we install Minikube. Great. Right? And then let's say that we have a cloud instance, which we're going to just, in this case, say we have Azure, right? So let's get into this. So if we have Azure, it's a giant cloud instance, and let's make it big because it's like the big cloud. And let's say in Azure we have, let's see. Better yet, let me just say that, because just to emphasize that it doesn't matter what we have here at all. I really want to emphasize what matters and what doesn't matter, because I get a lot of people who are like, you're using the wrong version of Kubernetes. It's like, wait, what? What are you No, code is code. You can take the code from one version and just put it in another version. It's like a copy-paste. If you've ever heard of copy-paste, you can't say, no, you can't use that copy-paste in rich text. You have to use that in TextEdit. Or you can't use that in TextEdit. You have to use that in Word documents. It doesn't matter. Copy-paste is copy-paste for the most part. Of course, there are variations of it. TextEdit has fewer features, just like lightweight. It's like a lightweight Microsoft Word. So let's say in the big one we have the official K8 Kubernetes from Google, I guess. I guess it's from Google. I don't know. Whatever. It doesn't matter. Like some big fancy version of Kubernetes, right? And let's say that we build something here. And maybe we even started a project here and we're like, oh, okay, I built this thing. And it would be painfully convenient if I could somehow create like a little way that just makes it easy for me to have sort of like a DevSecOps flow to make it easier to just like send data across Kubernetes to make things talk. What we could do is we could set up like a little tool called Azure Arc. And then we could make this little tool called Azure Arc have conversations with this wonderful thing I've been talking about because it's just so convenient, K3D. And then we can go ahead and have K3D talking to Azure Arc, right? And maintaining certain things, maintaining whatever we're trying to do, and then we can have whatever's going on with all of this stuff down here. We can have it go and do things over here, and ultimately we can just make all of these things be friends together. So we can say that this is friends with this, and we can say that this is friends, I guess, through this with this. And it's a little more complicated. I'm really dumbing it down. but the idea stands, where then maybe we even have it maybe go in some cases more like this, which is actually probably makes more sense. So really, I guess what makes more sense is this. And so then we can basically just have like a little channel where like this is the stuff that we like what it's looking like, and it's like ready to just kind of like this is what we synchronize our little like development space or whatever we're trying to do down here. Maybe we just want to like make it simple to just pipe that over in a way to where also what is having K3D allow us to do is if we have like Docker, right? Let's say that we have Docker. It's just like toss it down here somewhere. Because K3D requires Docker. It's Kubernetes and Docker, basically. Kind of like kind. But if we have Docker sitting here and it's running and all this good stuff, let's say that we ever want to like make modifications to this communication layer. Because Docker is something that's really easy to just like modify things in, then we also get the benefits of basically being able to like manage things like volumes with Docker and other things, and like image management, and who knows what else. Things that with Kubernetes are actually really confusing and really complicated. So let's actually just make this color according to this thing right here. So maybe we use K3D because with K3D, we can sit here and use Docker as an extra layer where whatever we're sending into some form of production, then like this is an isolated layer. We can make this talk to this, whatever. But Docker makes it really easy to make images and things to send to Kubernetes. Let me just emphasize this. Why Docker? It's a little more complicated than this, but it's much easier to come up with like a development flow with Docker. Docker makes it really easy to just like inject things into Kubernetes, like build thing, inject, build thing, inject. And a lot of the things that you can build in Kubernetes, let's say that there's some stuff that you like don't want to do the manual stuff for, you can sit here and you can have basically like things developed in your Docker instance basically like push their way down here and then also talk, here, and basically just you can use Docker to make all of the things in Kubernetes that are basically like a nightmare, especially with like generating images, building images. If you're wondering why Docker in Kubernetes, why Docker? Images. Let me just put that on the screen too, because that's a good why Docker. Images. I don't know a better way to put it. But Docker makes image construction, image management, image deployment, image modularity, image everything. Jordan, is it hard to build things like images in Docker to your experience, would you say, once you've like messed with it a little bit?
No, not particularly, and it definitely makes deploying super easy. And I mean, because once the image is there, then it's just a matter of pressing a few buttons to tell it to do what to do with it. So
exactly, images. Yeah, and then I guess the question that next would be like, what would you say in terms of like building images in Kubernetes? Like, Kubernetes is confusing enough. Like, how do you feel so far with your existing knowledge on image building in Kubernetes? Does that sound, I guess, simple in comparison, even though you don't spend as much time in Kubernetes?
No, I mean, definitely not. Most things with Kubernetes is, a little more difficult, I would say, than with Docker. I mean, obviously it depends on what you're talking about, but Docker is kind of more of a developer's sandbox, I would say, and Kubernetes is a little bit more of like a production ready environment, right? Where you have a lot of like the safeguards built in and all of that stuff, but that consequently getting something deployed and optimized in Kubernetes is definitely not as simple as it is in Docker.
Yeah, and that's more or less exactly right. And so it's, you can even have Docker and Docker, and then have Kubernetes in Docker and Docker. I mean, you can just create like crazy Inception things with Docker.
That's
like,
it's very confusing.
If you want Docker to be like secure, jungle gyms. Just build Docker jungle gyms, and then secure those Docker jungle gyms with more Docker jungle gyms. You can have. Talk about someone trying to figure out how to get through your Docker environment, through your Docker vulnerabilities. They're like, haha, I got through this Docker layer. And they're like, wait a minute. Under this Docker layer is a container D layer. And then if they get through that, they're like, wait a minute, there's another Docker layer? And then they get through that and they're like, there's another Docker layer under the... What is going on here? Anyways.
Which realistically, they would have gotten bogged down and quit a long time ago.
Yeah, pretty much. And then they would have just reverted back to a SolarWinds strategy because that's much easier. Oh,
yeah, exactly.
People aren't going to breach you through Docker most likely. They're going to breach you through phishing. They're going to breach you through some other thing. They're gonna breach you through your supply chain. I guess if you're using Docker for your supply chain and you're not monitoring it or layering it or vulnerability scanning it or any, okay, then shame on you. That goes for not just, that's not a Docker problem. That's a you should have done those things yourself thing. I guess I get a lot of questions about a lot of things security wise. You're like, isn't that unsecure? And they're like, isn't that unsecure? It's like, you know what's unsecure? Not using multi-factor authentication and writing your passwords on sticky notes, and then also making sure that like you're using a VoIP that's highly exposable with your multi-factor authentication, so that it's really easy for people to also get your multi-factor tools and access to that too. That's a bad idea. But using Docker, much more secure than what I just explained. So is like, if you're using things like proper security, you're using things like VPNs, using things like multi-factor authentication, properly managing your secrets, and then if you do know that a system has certain levels of like vulnerabilities, honestly, putting K3D on top of Docker means that apps running in K3D, you're running a container D layer, which then puts a layer of isolation on top of Docker's container engine. And also, Kubernetes has deprecated the Docker engine compatibility, so Kubernetes actually isn't compatible with Docker engine anyways. And so whatever would impact a K3D cluster won't impact a Docker container the same way. So by mixing the types of containerization engines you're using, you're actually getting some benefit there, where they just have different vulnerabilities, which means there's a lot more ground to cover from a security standpoint too. So for those who are kind of security nerds about some of that stuff, that's something that might be interesting. It's obviously a lot more complicated than that. We have overly simplified a lot of this stuff.
Yeah. Yep.
But that is, the big one. And then really, if you are trying, like, how do we set up a network? Because if you're trying to set up like a K3D, like, do you want to set this up on your home router? Do you want to set up a router inside your home router? What do you want to do? Well, that's a good question. So I guess like if someone were to try to get started with one of these Kubernetes configurations, and let's say your home network example. Let's say you have a home network. Whatever is going on in your home network, one thing that you probably have is a modem. And another thing you probably have, which I'll just also make yellow, is probably a router.
Mm-hmm.
Yeah. So this is more or less the beginning of, we have our home network. And if we're trying to get ready to figure out how to start using things like Kubernetes, then we're going to start here. And so if you're going to set up a Kubernetes system or a Kubernetes cluster, generally speaking, there are some things that we can think about, which I guess it depends on what you're trying to do or what you're trying to accomplish. If you're just trying to build like a small home project, then it's probably just fine to just, like plug in a test system. And that's generally not a big deal. And when you do this, what you're going to run into is anything that you do that sort of like exposes this test system to the outside world can, in theory, expose your entire network. So, generally speaking, just make sure that your router or whatever you're using, let's see. Router security matters. So, manage your security there. A lot of routers have firewalls built into them. A lot of routers have a lot of little features and things like that built into them. But ultimately, like, when you're trying to get one of these things configured, for the most part, you can just plug in a system and just make sure that the security of your system's working. But what if you suddenly are like, this test system was cool and all, but I just want something bigger and badder. Well, some ways that you could go and create like a full-on cloud inside your home, just like with normal consumer grade things that have features in them that allow you to do fancy things with consumer grade things is you could then go in here and you can add another router. And generally speaking, routers generally have have firewalls. I mean, but let's say that you then wanted to get more serious and maybe start trying to host something. And these are some interesting things that you could think about. But let's say that you then wanted to create something that you can, like host things to the internet on. So we'll just say this is exposed to the World Wide Web. So if you want to start exposing things, then it makes a lot more sense where then like having a lot more security matters and things like that. But at this point, you can do this thing where you, instead of having like your host system, it probably makes more sense to go ahead and start setting up a full-on cluster. So what you'd need at that point, if you want to really play with Kubernetes and you really want to start trying to play around with like Kubernetes and Docker and all those things, is you're going to need a switch, like a network switch. And then a network switch is going to let you add more devices and more hosts to your network. So maybe you then have a number of systems. So maybe you now have multiple systems. So now you have a worker system, but now you basically have like a cluster that's exposed to the internet. This whole little configuration right here is something that anyone can build inside of their home. You have to get the resources, things like that. And there are different ways to set up a network, but this is just like a basic way for like, what are you doing if you're not hosting anything on the internet? And you don't have to have like 2 routers or anything like that. That gets a lot more complicated because you don't want to have two DHCP servers on the same thing and routers.